Hello statistics students, this is Dr. Bielingmeyer with a Chapter 12 homework review. Questions 1 through 4 belong to this little vignette. Mosfeldt et al. 2012 collected data on 792 patients aged 60 or over who were admitted to a hospital in Denmark with a hip fracture between 2008 and 2010. They reported an elevated creatinine level upon hospital admission for a hip fracture is associated with almost threefold increase in mortality risk. You can look at the specific markers they used for the millimoles per liter in the parentheses. Question 1, what is the independent variable? It is creatinine level. What is the level of measurement? It is interval ratio. You'll notice that I'm saying interval ratio and not distinguishing between the two because when it comes down to actually doing the statistical analyses, interval and ratio are considered scale and there is no difference in how that is interpreted. Question 2, what is the dependent variable? Mortality. What is the measurement, level of measurement? And that is nominal. Question 3, what type of sample is it? Convenience. And is it probability or non-probability? It is non-probability. Question 4, the researchers chose to use a regression model. Should they perform a linear, multiple, or logistic regression model and why? They should use logistic regression because the outcome or dependent variable is at a nominal level with only two categories, meaning it is binary. Questions 5 through 10. In another study, researchers randomly selected 5 hospitals with orthopedic units in the United States and collected data from all male patients over the age of 60 admitted with hip fracture. These researchers then report that admission levels of creatinine and hemoglobin can be used to predict the number of days the patient will need to stay in the hospital. Question 5. What would be the independent variables? That's creatinine and hemoglobin levels. And what level of measurement are they? That's interval and ratio. Question 6. What would be the dependent variable? That's number of days in the hospital. And again, it is interval ratio level. Question 7. What type of sampling method is this? And this is a cluster sampling. Is it probability or non-probability sampling? It is probability sampling. Question 8. Why might these researchers have chosen to exclude those admitted with a hip fracture who are younger than 60? Well, your answers might vary from this, but a couple of things to consider are that those with hip fractures under the age of 60 are more likely to suffer fractures which are not related to age, such as trauma or maybe a disease process. And the blood levels may not be helpful to predict hospital stays for this population. Question 9, would it be appropriate to use these results to predict the length of stay for female patients over the age of 60 with hip fractures? Why or why not? No, because the sample only involves men, so it is not representative of a population of women. Question 10, if these researchers had already established a causative relationship exists between these variables and asked you for a statistics consultation, what would you tell them is the appropriate regression technique to apply and explain? This would be multiple regression because you have multiple independent variables and a dependent variable that is the interval ratio level. Question 11. According to the SPSS output, what percentage of the variance in health knowledge is explained by age and academic knowledge? And the answer to that is found in the R-squared. That explains the percent change. So R-squared was 74.7%, and the adjusted R-squared, which takes into account for some error, is 74.3%. So let's just look at R-squared. 74.7% of the variance in health knowledge is explained by age and academic knowledge. If you need to review those concepts, go to page 224 and 228 respectively. Question 12, is the R-squared significant? Explain your answer. The answer is yes, because the associated p-value or significance level is 0.000. Now I will tell you on page 241 that there was a mislabeling of a column. So if you look at that page, you see method in the far right, and then you go down to the next bold area, it says R-squared change with that 0.000 under it. That was really supposed to be labeled significant F change. So the significance is that 0.000. So we understand that that was challenging because the column was mislabeled. But if you see sig, that means your p-value. Question 13, should the nurse researcher include both independent variables in her final model? Explain your answer. The answer is no, and let's look at why. The beta for age is 2.711 with a significant p-value of 0.000. However, the beta for academic knowledge is 0.023, which is insignificant with a p-value of 0.43. So you would not include the insignificant variable. Number 14, if the nurse researcher includes both independent variables in her prediction equation, her predicted health knowledge score will be incorrect by an average of how many points? For this, you need the standard error of the mean, and that is 2.13687. You could have answered 2.14 if you rounded, but depending on how you dealt with your significant figures, that's what it is. Question 15. According to this model, every 1 year increase in age results in what change in the health knowledge score? For this, you need to the standardized age coefficient, which is 2.711. Therefore, for every 1 year increase in age, there is a 2.711 point change in the health score. Now, number 16, I'm going to pull up a Word document for you. Right here, number 16. Now you can pause the video and look at this for a minute if you want to, but I put your whole regression equation there, and then I reminded you from the text, this is right out of your text, what these things mean. The only thing that we're not going to pay attention to while we're doing this calculation is the standard estimate of the error, because nothing is perfect, so there is error involved in the equation, and they do account for that, but for while we're calculating what we need for this class, we are not going to account for that. So I encourage you to write that formula down and label the parts. So if you look at the 41.89, that is the constant. And then if you look here, your constant is the value of y, so your outcome variable, when the value of x, your independent variable, is 0. And then you have the 2.711, and that is your beta coefficient for your variable of, in this case, age. And the subject is 15 years old, so that's where that 15 comes from. And then the 0.023, you're looking at your beta coefficient for, in this case, knowledge, and then the score on the exam is 70. So that's where those numbers came from. And then you do the math and you come up with 84 point something, but 84. Okay, so that was 16. We have a ways to go before we get to 21. So let's do 17. What type of sample is this? It is a random or probability sampling. 18. A researcher working with military officers would like to use the data he has collected from them to predict their health knowledge scores based on this research. Would this be an appropriate application of this prediction equation? Why or why not? It's really not appropriate because of the age range. The sample uses teens and the military officers would be older. Predictions should not be made outside of the limits of the data collected. Changes in things like demographics from one population to another, such as age, geographic location, educational level, impact generalizability of results. Also remember, there was an insignificant independent variable included in the model, so that impacts how you would want to interpret that study. Question 19, does the model explain more or less of the variance in the health knowledge score? The model explains slightly less of the variance in the health knowledge scores. And it's a small change. The R-squared change for knowledge and age is 0.747. But without the knowledge variable, because it was statistically insignificant, the R-squared change is 0.746. The independent variable knowledge being insignificant equates to a small change in the numbers in the R-squared change, which means the second model has on average less error in the predicted outcome value. Question 20, in which model is the predicted outcome more accurate? It's the second model, like we just reviewed. After removing the insignificant independent variable, has a more accurate predicted outcome because the standard error of the estimate is smaller. It goes from 2.13687 down to 2.1337. Okay, now we're on 21, so we have another equation, and I just reminded you here we're not dealing with the E part of the equation. So using this prediction equation, if a 15-year-old, here you have a 15-year-old scored a 70 on the exam, on his academic knowledge exam, what would you predict he would score on his health knowledge exam? And there's your constant, and there's our coefficient with the 15-year-old, and we would predict that his score would be an 80 on his academic knowledge exam. I'm sorry, his health knowledge exam. Excuse my misspeaking. Question 22 to 25. This sample includes 9 teens age 14, 12 teens age 15, 25 teens age 16, 27 teens age 17, and 45 teens age 18. Question 22 asks you to show this frequency distribution graphically. So you would go ahead and graph that depending on what kind of graph you think shows the data the best. Remember, your frequency goes on that vertical y-axis. Question 23, what level of measurement is age in this sample? It's interval. And question 24, calculate all appropriate measures of central tendency for this variable. So the mean is 16.737, the median is 17, the mode is 18. Is age normally distributed in this sample? And you shouldn't have to do any calculation after you figured out the mean, median, and mode. The answer is no, because if it were normally distributed in the sample, the mean, median, and mode would have to be equal. Question 26 to 28, Khan, Sobke, and Alhomida in 2015 examined 75 patients to assess the association between fasting blood sugar, measured in millimoles per liter, and glycosylated hemoglobin or hemoglobin A1C levels, measured as a percentage, and reported the following regression equation, which can be used to estimate hemoglobin A1C levels and from a fasting blood sugar level. So from this equation, you know that an increase of 1 unit of fasting blood sugar is associated with what change in hemoglobin A1C? An increase of 0.387 in the hemoglobin A1C. Question 27, the researchers also examined the independent variable of gender, but did not include this variable in the final regression. Why do you think gender was not included in the final regression? So remember, if there's an insignificant value or variable, then we don't include that in the final model. So gender was not a significant independent variable and was not included to minimize the prediction error. Question 28, the researchers report that ethnicity was not measured in this study, but has been reported to be significant in other similar studies. If the study were repeated and ethnicity was included, and if none of the independent variables was then significant, we would know the original study that reported fasting blood glucose or sugar was significantly related to hemoglobin A1C had made what type of error. So that would be a type 1 error. So you're either correct or a type 1 error when they found an association that was not there. So the Khan et al. 2015 study also reported the following regression equation and reported that hemoglobin A1C could also be used to predict fasting blood sugar. So I have 29 and 30 right there. If hemoglobin A1C is 8%, and you'll see I just filled it into the equation, there's the 8, minus 2.528 equals 8.112. Then we have question 30. If hemoglobin A1C increases by 2%, so here's your 2%, what would be the predicted change in fasting blood glucose? 2.66 increase in millimoles per liter. That concludes the homework review for Chapter 12. I would like to just remind you, as we're really winding down in the course, if you're having struggles with any information, and you have gone to the textbook and reviewed lectures and worked through things again on your own, talk to the tutors. Please don't forget that the professor is here as well. We're here to help you succeed in the course, and we're happy to do that. So I hope you are doing well and things are coming together at this stage of the game. Regression is really a fun topic, so I hope you agree with that. We will see you soon.